Was that page 136? Is that where it's at? So let's take a look at it. What's up, fellas? All right. So we have the kids that are 10 to 13, and we have the kids that are 14 to 17. Breakfast or no breakfast. You have 40, 12. Hey, is there an error there? They say it's 47. What should it be? 52. Yeah, there's an error. Just caught that. Boy, this dude can't add when making worksheets. All right, and that's what? They say 43, but what should it be? 38. Holy cow. We goofed that boy. And then the other way, go 54. That's right. And 36 is right. And it comes out to 90 both ways, right? Is that really 90? 60, 90. 90. Okay, cool. All right. So please note there was a couple of errors in the actual problem. I didn't catch that yesterday, and I apologize. So let's just do this together. All right. So data was gathered related to middle school and high school students and whether they tend to eat breakfast or not. This is the table. Okay. So we want to say that mu is breakfast. Yes or no. And so then we can create our null and our alternative. We could say, excuse me, our null is independent and our null is dependent. Okay, so that's different than our nulls have been, but that's basically the long and the short of it. Okay, so I gotta make sure I do that right. Write this down. Okay, that worked. All right. All right, so let's go through. I'm going to do this. So if we're talking here, we're going to go 54 times 52 divided by 90. Is that okay so far? I think I have that right. Yep. And this is to find the expected value. And then to do this one, this is multiply them out, right? Did I multiply them all? I added them. Okay, so then I'm going to go 54 times 38 divided by 90. And then if I go to this one, this is just finding me all the expected values. 36 times 52 divided by 90. And then this last one is going to be 36 36 times 38 divided by 90. All right, so bust out on a calculator. I'll make each of these decimals. 54 times 52 divided by 90. So that's 31.2. 54 times 38 divided by 90. 22.8. And 36 times 52 divided by 90. That's 20.8. And then 36 times 38 divided by 90, 15.2. Oh my gosh, that's supposed to be a 5. That's supposed to be a 2. All right. All right, so each of those independent, excuse me, oh my gosh. So our expected value for a 10 to 13-year-old to eat breakfast is 31.2, but we observed it being 40. Our expected value for a 10 to 13-year-old not to eat breakfast is 22.8, but we have a value of 14. Our expected value for a 14 to 17-year-old to have breakfast would be 20.8. We have 12.2, and then our expected value for a 14 to 17-year-old not to have breakfast comes out to 15.2, but we observed it being 24. Okay, are we good so far? All right. So now we got to get into our chi-squared. Oops, come on, baby, come on down. So our chi-squared is going to be, make sure I have the equation right. Chi-squared is going to be observed minus expected quantity squared over the expected. Okay. I think we can do this. So for our red one, which is 31.2. So we observed, get on the right page. We're going to go 40 minus 31.2 quantity squared divided by the expected 31.2. So calculator, 40 minus 31.2 squared divided by 31.2. So that comes out to 2.48. Then our green one is 14 minus 22.8 quantity squared divided by 22.8.
You have other pencil.
Yeah. Take that one. So that comes to 3.40 rounded to 2. Then the blue is going to be 12 minus the 20.8 quantity squared over the expected. So 12 minus 20.8. That comes out to 8.8 divided by 20.8, 7.37, 3.72, excuse me. And then the black one, we have 24 minus 15.2 quantity squared over the 15.2. All right, so 24 minus 15.2, square that answer, divided by 15.2. So 5.09. And we can add those up. So 2.48 plus 3.40 plus 3.72 plus 5.09. All right, so we get 14.69. Okay, so this is my chi-squared sum. We'll probably have to round that to 14.7, but that'll be fine. Degrees of freedom. Our degrees of freedom is going to be 2 rows minus 1, 2 columns minus 1. 2 minus 1 is 1, 2 minus 1 is 1. Our degrees of freedom is 1. So, being our degrees of freedom is 1, and our chi-squared is going to round to 14.7. I might have to round to 15 depending on how it works. This is where you're going to jump onto Desmos. The degrees of freedom of 1 does not look like a bell curve at all. It actually looks like a um, natural log curve is what it looks like. But we can do it. All right. All right, my Cherry Creek. Schoology. Courses, stats. Last week's folder. Tommy, you are an aggressive typer there, pal.
I know.
Love you, man. All right, degrees of freedom 1. If I change this to degrees of freedom 1, notice it looks like a natural log curve, a negative natural log curve. And then we said our chi-squared value was 14.69, so I think 14.7 will work. Come on. There we go. All right, so we get a p-value of 0.30126. Okay. So that means our p-value 1, 2, 3, 1, 6, 1, 2, 6. So my friends, is that p-value smaller than 0.05? Okay, so what can we do? Reject the null. Very good. This is small, so we can reject the null. All right, which means, let's go back up to what our alternative was. So we said that age and eating breakfast is dependent. Okay? That's the long and the short of this whole thing. That is a big old problem. And this is also why I want to break up the the test as 2 parts. Okay? All right. Friends, let's go to check out 7.6. So I'm on page 130. No, I take it back. Not 130. 7.6 back here. Okay, page 57. I might have to do this over 2 days if that's okay. It's not because it's hard. All right, so we're back to our Atlantic, Pacific, and Indian Ocean category 1, 2, 3, 4, 5. So this is the chi-squared test for homogeneity and collapsing variables. Okay. So we're looking at our data. If we start taking a look at it, it says H naught says the 3 oceans possess the same distribution of hurricane intensities. The alternative, the 3 oceans possesses different distributions of hurricane intensities. And then it says if we reject the null, we find strong evidence that 3 oceans possess different distributions of hurricane intensities. If we fail to reject the null, we fail to find strong evidence that 3 oceans possess different distributions of hurricane intensities. Otherwise, the mathematics degrees of freedom assumptions method for calculating the p-value would be the same. Okay. Now we saw that yesterday when I kind of worked that out. Like that is a ridiculous, huge thing going up to get the expected value and go through there. All right, so we noted that the assumptions are not passed for this particular chi-squared test. Indeed, many of the expected values are below 5. This is a significant problem. It undermines the test results of our hypothesis test. However, the technique is often referred to as collapsing categories can be used to rebuild the table. So if you flip the page, notice they still have Atlantic, Pacific, and Indian, but they have category 1, 2, and then they have category 1, 2, and then 3 through 5. So what they did is category 1 stayed the exact same to give us 46. Category 2 stayed the exact same. And what they did is they went back and said, okay, if I add up 3, 4, and 5, it's 10 plus 5 plus 2, which gave me the 17. And then I get 15 if I go back to the 3, 4, 5 on the other, and then I get 4 here. And this gives us 36 in this space. And then we have totals over here. This becomes a much smaller idea, but it allows categories which are small to be put together, so then we could start basing our information on that. So the claim here in the paper says this seems to undermine the data, and actually collapsing variables does lose a level of precision, because basically our degrees of freedom is going to drop because it goes from 5 columns and 3 rows to 3 columns and 3 rows. So our degrees of freedom will definitely drop. Okay, the chi-square inherently involves categories of variables, which gives us a lot of choice about how to construct the categories. In this diagram, all expected values are larger than 5, and we are free to proceed the test with confidence. Okay, so that's kind of why you start collapsing categories down. Okay, it's not because you're fudging the system, it's just like you just noted that the 3, the 4, and the 5 were actually smaller, and then getting the 17, 15, and 4 are closer to the categories 1 and 2 when you combine categories 3, 4, and 5 together. Okay, so it's not, it actually creates less work on the statistics going through it. So what do we say? Let's have you get a start on page 137 only. Okay, and you can play around.